Hello, dear students. How are you all? Yeah, you all are great. Perfect. So, what have we learned in the last class, if you can remember? Yeah, we have learned about simple interest, compound interest, and yeah, I hope you all have solved few examples on that as well. Yes, have you done that? That's great. That's great. Okay. So, dear students, today we are going to learn more on compound interest. Like we'll be seeing like more complicated sums, more complicated problems on those. Okay. So let's not waste time and quickly start with the set of questions which we have. Yep. So here is my screen. I'm sharing my screen with you. Yep. You can see the screen, right? Okay, great. Okay, so what actually we are going to learn? So we are going to see how compounding as in what? Calculating the rate of interest in certain time intervals. So it will be a annual compounding, it will be a half yearly compounding, a quarterly compounding. So half yearly means 1 by half, that is 6 months, you can say. Yeah. Then comes the quarterly compounding, like again 4 months. Yeah. Likewise, general compounding. General compounding will be like general calculating when they will be giving you some time period. And we are going to see some applications of compound interest as well. Okay, perfect. So first of all, what is annual compounding? Okay, annual means, you know, annual is nothing but it's yearly. Yeah, it is nothing but it is yearly compounding. Annual compounding is yearly compounding. So the effective annual interest rate is the real return on an investment, accounting for the effect of compounding over a given period of time. Yeah, so simply annual compounding is nothing but it is the interest. Yeah, it is the interest which you will be getting on an investment for a particular period of time. That is like your time. Yeah, so we this is bit similar to the compound interest formula. You know, compound interest is equals to a minus p, and for a, which formula we used? A is equals to p into bracket 1 plus r upon 100 raised to n. Yeah, yes, this formula we are going to use, but later on I'll tell you where are we going to use this formula. Okay, so let's just quickly solve this example. Okay, I guess we have solved this example in the last class, if you can remember. Yeah. Okay, so I'll say that this we have solved in node 3. Yeah, this we have solved in node 3. Today is your node 4, class 4. Yeah, or class 3. I'll write class 3. Okay, perfect. Okay, because that was the one associated with the normal compounding, normal compound interest. Yeah, so this is half yearly compounding. So you have to keep two things in your mind. When the question comes to you that you have to calculate it half yearly. So when they say half yearly, what you have to do, you know, half yearly means what? It is 6 months. Yes, yes, dear students, it is 6 months, or it is 2 times a year. Yeah, it's a 2 times a year. So your number of years are going to be what? Doubled. Number of years are going to be double. Whatever time period they give you, you have to make it double. Like say if number of years is denoted by n, then you have to make it 2n. This is the first important thing you have to keep in mind. And the second important thing is the rate. R. R should be halved. What should we do with that? It should be halved. That means it should be R by 2. These are the very two important things associated with half yearly compounding. Yeah. See, don't get confused. The number of years are double. That means n becomes 2n. Rate of interest R becomes, what does it become? It becomes R by 2. Okay. Perfect. Okay. So let's quickly solve this example. So yeah, find the amount and the compound interest. So you have to find the amount also. You have to find the compound interest also on $8,000. So this is your P. 10% per annum is your rate of interest. 1.5 years is your N. If the interest is compounded half yearly. So here they are specifying in a question that it is half yearly. Okay. So first, what do we calculate? Before calculating, we have to do something. Yes. So N, what is N? N becomes 2N. which is nothing but 1.5 into 2 is nothing but 3 years. Yes, dear students. And the rate of interest becomes R by 2. So which is 10% by 2 becomes 5%. Yes. So first you have to do this and then you have to go for calculating your amount. So amount is nothing but P into bracket 1 plus R upon 100 raised to N. Therefore, A is equals to what is principal? 8,000. Yes. So 1 plus rate of interest 10 या 5. What will be taking? Yes, of course, student. We are going to take 5. So 5 by 100 raised to N. What is N? 3. Correct. Therefore, A is equals to 8,000. This becomes 5 and 20. So 1 plus 1 by 20 raised to 3. Therefore, A is equals to 8,000. 21 by 20 raised to 3. Yup, after that. Therefore, A is equals to 8,000 into 21 by 20 into 21 by 20 into 21 by 20, 2, 2, 2, 0, 0, 0, 0, and this 2, this 2, this 2, this 8 gets cancelled. Simply, you have to get the cube of 21. So, I have calculated it, and the cube of 21 is nothing but 9261. $9261. So this is your amount, and from the amount you can quickly get what you can get, dear students. You can get the compound interest. Therefore, compound interest is equals to amount minus principal. So your amount is $9261 minus principal is $8,000. So your compound interest is nothing but $1,261. Yeah, see, it is so easy. Just you have to make the number of yours double and half the rate of interest. Yes, perfect. Now quarterly compounding. Again, for quarterly compounding, you have to keep two things in your mind. The number of years becomes 4 yen and the rate of interest becomes R by 4. See, it was half. That's why it was divided and multiplied by 2. But it's quarterly. That means 4 parts are there. So, the number of years becomes 4n and the rate of interest becomes R by 4. Only keep this thing in your mind. Yes, these are the formulas. These are a bit lengthy formulas. You can note them down. But in a shortcut way to just memorize and summarize, you can keep this. Okay, so if I just quickly compare here and tell you if it's half or if it's quarterly, what happens? Your n becomes 2n, your n becomes 4n, your r becomes r by 2, and your r becomes r by 4. See, this is so easy. Yes? Okay, chalo, quickly. Find the compound interest. Yes, you have to get the compound interest on 10,000. This is your principal. If Ron took loan from a bank for 1 year, so n is 1, at 8% per annum, your rate is 8%, compounded quarterly. How it is compounded? Quarterly. Okay, so they have told you to calculate compound interest. So we can't calculate compound interest directly. For that, we have to get the amount first. So amount is equals to P into bracket 1 plus R by 100 raised to N. Therefore, A is equals to 10,000. First we have to convert. So number becomes what? N into 4. So becomes 4 years. And rate of interest becomes R by 2, which is nothing but 8 by 2, which is nothing but, R by 4. Sorry, it is R by 4, which is nothing but 2%. So 1 plus rate is what? 2% by number of years is 4. Therefore, amount is equals to 10,000. This becomes 1 by 50. So 1 plus 1 by 50 raised to 4. Therefore, A is nothing but 10,000. 51 by 50 raised to 4. Yes, so it's only again calculation. So A is equals to 10,000 into 51 into 51 into 51 into 51 whole divided by 50, 50, 50, 50. You cancel out all the zeros and you calculate it. So when you do the huge multiplication, you are going to get the value as 10824.32, which is an approx value. Yeah, because there is division also. Yeah. So this is your amount. Now your compound interest is nothing but amount minus principal. So compound interest is equals to 10824. I'll take just that number. And okay, I'll consider 32 also minus 10,000. So compound interest is nothing but $824.32. So this is your answer, dear students. Understood the difference between compounding quarterly and compounding half? Perfect. Okay. Yeah. The next part is general compounding with the time period T. Okay, so this is going to be a general compounding. You can use this formula now. Yeah, I told you now we are going to use the formulas later on. Yeah. So what is the formula? A is equals to P bracket 1 plus R by M into NT. Now here you have to get to know that what is M over here. So M is nothing but number of compounding periods or time. So whatever the number of compounding is, like how it is compounded and how many the intervals of time maybe. Yeah. So that is over M is over here. Okay. Perfect. As I said, there are some applications of compound interest also in the starting. Yeah. So what are the applications of compound interest, dear students? So compound interest can be used when you want to get the growth or decay. Growth means growth and decay means which is decreasing. Yeah. Any quantity which increases or decreases so that the amount at the end of the each period of constant length bears a constant ratio to amount at the beginning of that period. So this ratio is called the growth factor if it is greater than 1 and the decay factor if it is less than 1. Yeah. So we are going to apply compound interest when we need to calculate the growth and the decay, and appreciation and depreciation also. So appreciation, again, it is increases with the passage of time, and depreciation means it decreases the values. That's it. Okay. Perfect. So we have a quick example in front of us. Yeah. So what is that, dear students? In a certain, this is a application based. Okay. So this question is application based. Application based example. Okay. So see, you can see here. In a certain experiment, the count of bacteria was increasing at the rate of 2.5% per hour. Quickly I note it down. This is my rate of interest. Initially, the count was 5,12,000. Yes. So can this be a principle? Yes, of course. Find the bacteria at the end of 2 years. So this is N. Yeah. So find the bacteria. What do you mean by find the bacteria? Yes. What actually you need to find? Compound interest or amount? Yes, we have to find the amount. So A is equals to P into bracket 1 plus R upon 100 raised to N. Therefore, A is equals to P is 5,12,000. 1 plus, now it is 2.5%. So if you want to write 2.5, you can directly write 2.5 or you can write 5 by 2. Yeah, and into 100 as it is raised to 2. 5 ones are 5 20s are. Therefore, amount is equals to 5,12,000. So 1 plus, this becomes 1 plus 1 by 40 raised to 2. Therefore, A is equals to 5,12,000. This becomes 41 by 40 bracket square. So if you solve this, you get a huge amount, you multiply. So it is nothing but 537,920. So bacteria was, the number of bacteria is nothing but 53,79,7,000, no, 5,37,920. So this is a huge amount of bacteria which will be there in an experiment. This is the count of the bacteria. Yeah. Okay, so see, how do you recognize this is a compound interest problem? Yeah, because you know that by which rate it is increasing, by how many hours it is, and yeah. So you can correlate this with your basic compound interest formula and you can get it. Yeah. So you're not going to actually find compound interest here. You are supposed to get the, what we say, the amount. Yeah. Okay. So let us do some practice questions. If you can just quickly see on the questions, this is the one which we have done in class 3. So this is already done. You can just see the recordings and just you will be knowing that this is the already done. I would give you this as a homework because this is compounded quarterly. Okay. And one half yearly and one quarterly. One half yearly I'll solve here and one application based I'll solve here. Okay. Okay, perfect. So yeah, if I get the first one, quickly read the first one. Find the amount and the compound interest. We have to find the amount. We have to find the compound interest on $4,000. Principal, number of years, rate of interest per annum, compounded half yearly. So it is half yearly. So let's n becomes 2n, which is nothing but 3 years. Yeah. And rate becomes 10%. So becomes r by 2, which is nothing but 5%. I think we have done this problem also. I think the yeah, see, it's the same one, but this principle is changed. Yeah. Still, I'll solve and give you, dear students. No worries. Okay. So first you'll get the amount. A is equals to P into bracket 1 plus half yearly. So it is 3 P1 plus. Okay. So for this, I have one more interesting formula for you. Wait a minute. Let me give you that formula. That's a bit shortcut formula when you'll be getting this type of question. So that lengthy approach in your Olympiad. So that lengthy approach would be time consuming. Instead, you can use this formula. AN is equals to P into bracket 1 plus I raised to N. Okay, so this is a better approach you can take. Yeah, it is the same one but a bit simplified one. So you're keeping your mind that I should be in the decimals, not the ratio. Okay, so n means what? The number of years. So you have to find, therefore A3 is nothing but 4,001 plus 5% in decimals is nothing but 0.05. So you'll write 0.05 raised to what? 3. Therefore, A3 is nothing but 4,000 is 1.05 raised to 3. If you do this calculation, you get A3 as 4630.50. This is your amount. Now, if you want to get the compound interest, it is amount minus principal. So 4630.50 minus 4,000. So compound interest is nothing but $630.50. So amount is this and compound interest is this. Instead of going with the lengthy approach with the ratio part, you can go with the decimal part. Yeah, understood? So this also we completed. This we have already completed. This I've given you for homework. See, I'll give you some hints over here. If this is 1,500 is invested. So 1,500 is invested means this is your principal. At a compound interest rate, this is your R per annum compounded quarterly. How it is compounded? Quarterly. For 72 months. 72 months. So here this is months. So you have to first convert this into into year, and then you have to do it n by 4. Yeah, and you have to find the compound interest. That's it. Yeah. Okay, so let's do this one, the application based. The population of a certain city is 1,25,000. If the annual birth rate is 3.3% and the annual death rate is 1.3%, calculate the population after 3 years. There is one additional part, you have two rate of interest. So how are you going to do that? Yeah. So the fourth one, how are you going to do that? So first of all, I'll say my P is nothing but, wait, it is 1,25,000. My P is nothing but 1,25,000. They have given you a birth rate of 3.3%. They have given you a death rate of 1.3%, and the number of years is nothing but 3. Okay. So first of all, you have to get the annual growth rate. Yeah. First of all, you have to get the annual growth rate. So your annual growth rate, by how much it is growing. So how many are born minus how many are dead. So it is 3.3 minus 1.3, which is nothing but 2%. So this is your annual. So this is the very important part you would have to calculate at the initial level. That's why they have given you the different birth rate and death rate instead of giving you this direct 2%. Okay. Now, what are we supposed to find here? A, we have to use the A formula. A is equals to P plus 1 by, yeah, you can use this I formula, 1 by I raised to n. So this becomes 0.02. So therefore, A is equals to 1,25,000. 1 plus 0.02 raised to what is n? N is 3 over here. And when you calculate all this, you're going to get 1,32,651. That's it. So what is this? This is the population. So at last you have to write, this is your population after 3 years. Yes. So understood? See how this application based questions, they sometimes, see, the bacteria one was straight, but here they just confused you, not giving the direct rate of interest. Instead they gave you the birth rate and death rate, and with the help of that you calculated the annual growth rate. Okay, perfect. So I hope you all have understood the concept of the annual compounding, the half year compounding, the quarter compounding. Yep. Yeah, and you know how we have done two application based questions. So I hope you have understood that also. Yeah, so go with the set of questions, practice as many questions as you have. If you get any doubts, your ma'am is here to help you. Yeah, of course. Okay, dear students, so I'll take a leave. Bye then, keep practicing. Yeah, you have any doubts, get in touch with me. Bye bye, take care, have a good day ahead. Bye.